Hello guys, welcome to my YouTube channel. Those ones who have not subscribed, please subscribe, like, comment, and ensure you stay tuned to get more updates. So today we are looking at trigonometric equations back from the complementary angles we did the other time. So this question says solve 6 cos squared x is equals to 5 sin x for 0 for the range 0 to 180. So here we must apply Pythagorean identity, which is sine squared x plus cos squared x is equals to 1. But before we can, apply the Pythagorean identity, I want to take you through the process of deriving the Pythagorean identity. So look at this triangle. It's labeled ABC plus angle x inside. So here we'll get to use Pythagoras theorem, where we have a squared plus b squared is equals to c squared. Very common. I know you know that. Then here, after we've written down the Pythagoras theorem, we'll try to derive the values of a and b from now trigonometric identities, or rather trigonometric ratios. So we have the cosine and sine. Those are the major ratios we are going to look at when we are deriving the Pythagorean identity. So in this case, we start with the cosine of x. The cosine of x from SOHCAHTOA is adjacent, and you can see that the adjacent side is b for this angle x, and the hypotenuse is c. Cross multiply there, we get that b is equals to c, the cosine of x. And then therefore we go ahead and get the sine of x is equals to opposite angle x. The opposite is a and over hypotenuse. So we can be able to get the value of a as c, the sine of x, when we cross multiply. Good. So we can now substitute the values of a and b in our equation there. So we get that a squared, which is now c, the sine of x squared, plus b squared, which is c, the cosine of x squared, is equals to c squared. So from there, we can open the bracket. So we have c squared sine squared x plus c squared cos squared x is equals to c squared. Then we divide everything by c squared. We see c cancels c. We have sine squared x plus cos squared x is equals to, this part here cancels out to be 1. So we have is equals to 1. So this one here, this one is now our Pythagorean identity. That is our Pythagorean identity. Pythagorean identity. Yes, so we can now apply, looking at 6 cos squared x, and this side we have sin x. There's no relationship between cos x and sin x, but there is a relationship between cos squared x and sin squared x. So this is the side we'll change. So we have cos squared x is equals to, you can see that is 1 minus sin squared x. So having done that, we can substitute this back to our original equation. So we have 6 into cos squared x is 1 minus sin squared x. And then this is equals to 5 sin x. Good. So from there, we go and because this one, we haven't opened the bracket, we open the bracket first. So we'll have 6 minus 6 sine squared x is equals to 5 sine x. Then we can take this the other side and this one also the other side, so we have 6 sine squared x plus 5 sine x minus 6 is equals to 0. Then we can now, because we cannot work out this quadratic equation with sine x, we can now just say let sine x be something like so, where we'll bring down sine x to be y. So sine squared x is the same as sine x times sine x. So that is why when we open this one, it will be 6 sine, sorry, and that will be 6 y squared plus 5y minus 6 is equals to 0. And then we can solve this using PSF. PSF is product sum and factors. Product sum and factors. So product here is this number 6 times that number there. So we have 6 times 6, which is negative 36. We have sum, which is the coefficient of y. We have 5, and the factors are negative 4 and 9. Those negative 4 plus 9, you get 5. Negative 4 times 9, you get negative 36. So we just split the sum part, this sum part only. So we have 6y squared minus 4y plus 9y minus 6 is equals to 0. We factor out, we group first, we group 2 or we pair 2. Then we factor out a common term there. We have a common number or value. So we have 2y being common. So we have 3y minus 2, and then plus 3 is common here. So we have 3y minus 2 is equals to 0. Again, with these two brackets, the values must be the same so that you can say you factor it out. So we factor 3y minus 2 because it's common. And then we remain with the 2y. We remain with the 2y plus 3. So this one is equals to 0. So therefore, we are going to equate both the brackets to 0 and solve. So we equate both brackets to 0 and solve. So we'll get that. The 3y minus 2 equals to 0. Then therefore, y is equals to 2 over 3. Then the other one, 2y plus 3 is equals to 0. So y is equals to negative 3 over 2, which is just negative 1.5. Okay, so, but remember we said that it is the sine of x, which is equals to y. So y is 2 over 3. So we are saying sine x is 2 over 3, or sine x is equals to negative 3 over 2. So for negative 3 over 2, when we get the sine inverse, because we want the value of x. So let's start with this one here. So when we have sine x being equals to negative 3 over 2, the sine inverse of that is impossible because it's math error. So we don't take that value. So we'll take the sine of x being equals to 2 over 3, the positive value of sine. So to get x, we just get the sine inverse of 2 over 3. sine inverse of 2 over 3 is equals to 41.81 degrees. 41.81 degrees. So the first value of x here is 41.81 degrees. And remember, the range is from 0 to 180. So we now apply Form 3, or rather grade 11 concept, where we are talking about a unit circle where in the first quadrant all ratios are positive. In the second quadrant, where we have S, only signs are positive. The other one, T, only tangents are positive there. Only cosines are positive at C. Then you see sine x being equal to 2 over 3 means the value of sine x is positive. So where do we get that? We get the value of sine x in this quadrant and this quadrant. So does that tell you that at A we have already gotten the value of x, which is 41.81. So we need the second value of x at S, where signs are positive. At this quadrant here we have 180 minus x. This is x. This one is 180 plus x, and this one is 360 minus x. So for you to be able to get the angles whose value is the same as the sine of 41.81. So at S, we'll get an angle whose value is the same as the sine of 41.81. What do we do? It is just 180 minus x, and x is 41.81. So in this case, we'll take 180 minus 41.81. So this gives us 138.19 degrees. Okay, so when we want to get another angle whose value is the same as the sine of 41.81, we'll need to do the second rotation so that we go at A. So we take 360 plus x. But now that is way beyond our range, which is 0 to 180. So we only have two values of x, that is 41.81 and 138.19 degrees. So when what is the sine of 138.19? Confirm. Yeah, you should have confirmed that it is equals to 2 over 3, which is just approximately 0.6667. And so that is how we solve this question. It is very, very detailed, but I think you have absorbed and understood how we solve this question. So that is the end. I beg you to subscribe. Please follow for Facebook, share, like, comment, for us to be able to receive updates and even more lessons for the same. Bye.